Hey, Math 110 students, we are talking today about even and odd functions. Even and odd functions. So let's go ahead and start here. What are even and odd functions? This has to do with symmetry. So an even function is one that looks exactly the same mirrored across the y-axis. It is mirrored across the y-axis. So f of negative x equals f of x. And let me show you here on a graph what we're talking about here. So I'm going to share with you this right here. All right. Is that okay? It's too dark. I mean, it's too bright. So let's darken that. There we go. Now we can see our graphs. Okay. All right. So let's think about a graph here. I am going to graph something that is even. I'm going to graph y equals x squared, or also known as f of x equals x squared, right? So y is the same thing as the value you get out when you plug x into your function. So y is the same as f of x, all right? And so if we were going to graph some points here, when x is 0, y is 1, 0 squared is 1. When x is positive 1, excuse me, when x is 0, y is 0. 0 squared is 0. When x is 1, 1 squared is 1. Interestingly, when x is negative 1, okay, negative 1 squared, if you put that in on parentheses on the calculator, negative 1 squared is also positive 1. Okay, we could do a few more. We could do positive 2. Positive 2 squared is 4, but negative 2 squared is also positive 4. You need to put the negative in parentheses and then square it, and you would get positive 4. And what happens here? We get something that is even, okay? So when x is 0, y is 0. When x is 1, y is 1. When x is negative 1, y is 1. When x is positive 2, y is 1, 2, 3, 4. And when x is negative 2, y is 1, 2, 3, 4. And you'll see that this is mirrored, okay, around the y-axis. It has symmetry around the y-axis. Now, mathematically, just with symbols, what we say is that f of negative x equals f of x. For instance, f of negative 2 equals f of positive 2. And that's what we saw. F of 2 equaled 4, and f of negative 2 equaled 4. So you could take the opposite x, but you're going to get the same y. And what that looks like is something reflected across the y-axis. You can put in the opposite x's, but you still get the same y. This is even. F of negative x equals f of positive x. Okay, in words, you could put in opposite x's, but you will get the same y. This is even across the y-axis, okay? Now, the other thing we want to talk about today is odd, okay? And I'm going to do y equals x cubed. That's a pretty basic odd function, okay? Odd is that if you put in opposite x's, so you have f of x and you have f of negative x, you're actually going to get the opposite y's, okay? So f of negative x is going to equal negative f of x, okay? All right, so what am I saying again? I'm saying that the opposite x's then will give us, opposite y's. Now let's think about that for a moment. Let's do a little chart again, okay? All right, so if x is 0, 0 cubed is 0, okay? If x is positive 1 cubed is 1. What is negative 1 cubed, though? put that again in your calculator and put it in parentheses so the negative also gets cubed. -1 cubed to the third power is -1. So we have the opposite x's give us the opposite y's. Do it the same way with 2. 2 cubed is 8. -2 cubed, if you put that on your calculator, -2 to the third power is -8. So the opposite x's give us opposite y's. What does this look like when we graph it then? All right, 0, 0. When x is 1, y is 1. When x is -1, y is -1. When x is 2, y is 1, 2, 3, 4, 5, 6, 7, 8. When x is -2, y is -1, -2, -3, -4, -5, -6, -7, -8. Okay. And you're going to get something that looks like this. Okay. This is symmetric around the origin. Here's the origin where the x and the y axis intersect. This is symmetric around the origin. So if I flip this guy through the origin, I get this. If I flip this guy through the origin, I get this. And the way it works mathematically is that the opposite x's give us opposite y's. That is the definition of odd. Okay, odd, symmetric through the origin. Opposite x's give us opposite y's. Even, okay, symmetric around the y-axis. Opposite x's give us the same y. Okay, now, mathematically, how do we determine whether something is even or odd? Even or odd? Well, let's go back to our PowerPoint real quick. It's easy enough to see it with the graph, a little bit harder. Let's see if I can get this to come. A little bit harder to see it just with the math. So here's one that is really neither even nor odd. B, this is even, it's reflected across the y-axis. C is odd, it's reflected across the origin. And now let's do it with an equation. So we got g of x equals 2x squared plus 3. Okay, g of x equals 2x squared plus 3. So let me go back over here to my paper. All right, and so we want to know, is it even or odd? So what if it's even, that would mean that g of x would be the same as g of negative x. So we know what g of x is. Let's see what g of negative x is. All right, g of negative x is 2. In place of the x, we're going to put negative x. We'll square that. Plus 3. Let's see what we get. Okay, this would be 2. A negative squared is positive. So negative x squared is positive x squared plus 3. All right, so g of x does equal g of negative x. This one is even. This one is even. All righty. So that's even and odd. And our keyword for today is symmetry. Symmetry, because even and odd has to do with symmetry. Even, symmetric across the y-axis, and odd is symmetric, kind of catty corner across the origin. All right, we'll be back with more.